Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 84 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your gear up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 83. But before I do, I must ask, were you successful? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you are not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, now I will admit that this is a little bit of a tricky problem to solve, and I would bet that some of you were more successful than others at it, and it's kind of hard for me to exactly judge because I don't know how hard you put your homework through the paces to try to generate an error. But I'll tell you, most people with debounce switches, if you let me play with it, I can get that thing to malfunction. So I usually test my debounce strategies out pretty thoroughly. So look at what you did and then look at the way I'm doing it, and let's kind of contemplate how we can get the most robustly debounce switch. Sound good? I hope it does. So let me move out of your way, and let's start by taking a quick look at the circuit. It's pretty much the same circuit that we did last week, and let me come over here. Well, I ignore these extra 3 LEDs. Okay, ignore the extra 3 LEDs because that's for me to show you the solution to next week's homework assignment. But you basically have a push button and you have an LED. You have a push button and you have an LED. The right leg of the push button is connected over to GPIO pin 20, and the long leg of the LED is connected to GPIO pin 16. The short leg of the LED goes through a 220 ohm resistor down to ground. I established the ground rail by physical pin 38. Physical pin 38 establishes the ground rail, and then physical pin 36 establishes the power rail, okay? And then the left leg of the push button is connected down to the power rail. So we go power rail, and then we go over to GPIO pin 20, and then the LED is connected to GPIO pin 16, if that makes sense. That's a pretty straightforward circuit, and that's what we're going to be doing. Now, what was the homework assignment? I showed you last week how to connect an interrupt to a GPIO pin and look for a push button event, and I showed you how to do that, and I showed you the problem is that a switch does not cleanly open and close. You get bounces in there, and how are we going to deal with that bounce? So I think the first thing that we need to do is come over here and kind of do it on paper. Now, first of all, let's remind ourselves that we are dealing with a pull down resistor. Okay, we are dealing with a pull down resistor, and let's see, why is that? Okay, we're dealing with a pull down resistor, and the way a pull down resistor works is you have the switch, you have one leg of the switch hooked to the positive supply voltage, which I showed you in our circuit, and then the other leg of the switch goes to a pull down resistor and then to ground. Now, with the way we set things up on the Raspberry Pi Pico W, this pull down resistor is an internal pull down resistor. We just turn on the resistor that is already there. Now, what we need to see is in that configuration, the switch can be up and open, or it can be down and closed. And so when the switch is in the up position, you do not see the voltage over here. What you see is you see the ground. Why? Because there's no current through this resistor, so the voltage here is the same as the voltage here. And so what you're going to read is you're going to read 0 volts, which is a logical state 0. Now, if we press this down, when this comes down, then what this sees right here is it sees the positive voltage, and so that is going to see 3.3 volts, and that is going to be a logic 1. So as we go through this, just remember that you're going to read a 1 if the button is down, and you're going to read a 0 if the button is up. Now, use attaching an interrupt right here. The challenge that we have is we get bouncing. When we press the button, it doesn't just go to a 1 state, it bounces a few times. And when we release the button, it doesn't go straight to a 0 state, it bounces a few times. So realistically, this is sort of what happens. You're coming along, you press the button, and then you go to the 1 state, you go to the 0 state, you go to the 1 state, you go to the 0 state. I don't know, it might be no times or it might be 5 times, and then you finally stabilize on that 1 state. Now, when you release the button, the same thing, it'll go to 0, but it might bounce back and forth a few times. It might bounce back and forth a few times before it stabilizes to 0, and then you'll come over here and you will press the button again, and you'll have that same thing happen. Okay, and then you'll release it, and I'll sort of show it like that. Okay, so this is what we have to think through. Now, what you're going to have to think is, do we want to switch on a rising edge of a button push, or do we want to, so when I go down, I get a 0 to 1. That's a rising edge voltage signal as the button goes down. Do I want to trigger on that, or do I want to trigger on a trailing edge? And so what we could say here is that I could call this a rising edge, and what I could call this is, I could call this as the trailing edge. You can do it either way, but for this homework assignment, I said I am going to do a rising edge. Now, what problem do I have? If I look here, I have a rising edge here, a rising edge here, a rising edge here. That's 3 rising edge on the push the button down. And then when I let the button up, I have a 1 rising edge, 2 rising edge. And that might be really, if you got a clean button push, you might just get 1 rising edge. Or if you got a sloppy button push, you might get 5 rising edges. You really don't know, but you have some number of rising edges here, and you have some number of rising edges here. And how do we know that I have one that I want to count? I want to count only this one. Only this one. Okay, I don't want to do anything on those earlier ones. So you have to ask yourself, you look at the picture and you ask yourself, how do I know if I have the real rising edge? How do I know if I have a rising edge that I want to count? Well, really, I shouldn't say that this is the one that I want, but I want to make sure out of all of these, I only trigger on one of them, and on all of these, I don't want to trigger on any of them because those are false rising edges. So this is the way that I think of it. Okay, this is the way that I think of it. And I think I'm gonna see if I can get rid of some of that last stuff, clean up this picture a little bit. Give me a second to clean up the picture a little bit. Okay, like that. Now, this is what I am going to do. I am going to look for both rising edges and trailing edges. I'm going to look for rising edges and trailing edges. Well, let's look, and I'll just start and jump in here. Let's look right here at a trailing edge. You get a trailing edge when the button goes up, right? Because you go from 1 to 0 when the button goes up. And so I'm going to say that this was the time when the button went up. Now, when the button goes up, it is a result of the signal going down, okay? But physically, the button goes up and the signal goes down, so I'm going to call this T up for T that the button went up. And then I am going to call this T down, because this is the time that the button went down. When the button goes down, the signal goes from 0 to 1. And so up and down is the position of the button, not the position of the signal. Pause the video and think about that. So this is the time that the button is released, and this is the time that the button is pressed. Now, what I've got to do is I've got to delineate this from all of these false signals here. Well, how do I know that this is the one that I really want to use? I know that it's the real one because it came after a long delay, a delay more than a few tens of milliseconds. So this is the real one. Now, if I think about it that way, I am not going to count this one because it came after a short delay. I'm not going to count this one because it came after a short delay. Only this one came after a long delay. So I would ignore this one and I would ignore this one. Also on the downside, on the downside, I'm going to ignore this one and I'm going to ignore this one because they happen after a short down period. The only one that I'm going to really use is one that happens after a long delay. So what do I need to do? I need to keep track of the time that the button was released, the time that the button went up, and the time that the button went down, and I only toggle when the down happens after a longer delay after the button was released, okay? And that will eliminate all of these false signals, and that will eliminate all of these false signals and all of these false signals. Does that make sense? So what I want is I want T down this, and let me get further out of your way, T down minus T up, which had happened earlier. I want that to be greater than, let's say, 25 milliseconds. And if T down minus T up, this time minus this time is more than 25 milliseconds, I'm going to count that as a genuine button push, and then I'm going to do my toggle, or I'm going to do whatever. And so you might kind of sketch this and think about this, and then we'll go in, and then it'll make more sense when you watch me code. Okay, so let's see if we can come over here now. Let me get back up here a little bit bigger. Let's come back over to our code view here. All right, we're ready to go there. And let's jump in and start coding. Okay, so I'm going to say from machine import pin, because I'm working with those pins. Then I'm going to import time, just because I'm going to have to keep track of some timers. I will not use a time.sleep. And remember, the homework assignment was to not use time.sleep. Okay, I'm going to do import time. And then I have a button pin, and we said that was connected to GPIO pin 20. I have a red pin, and we said that was connected to GPIO pin 16. Now we're going to set up some global variables here. I'm going to say that I have press, the number of times that I press the button. I'm going to say that is 0 to begin with. And then the time that the button went up, which is the time the signal went from a 1 to a 0, I'm going to initialize that to whatever the present clock time is, time dot ticks underscore milliseconds like such. And then I'm going to go ahead and initialize t down. T down is equal to time dot ticks underscore milliseconds. Right, that's just because inside of that function, that callback function, I'm going to say something like, what was it we said in our little picture, that it was going to be t down minus t up. It was going to be the button, the button going down minus the button, the button going down minus the button going up. The button going down minus the button going up. So I need to initialize those to something so the program doesn't crash the first time through that function. Okay, and then I am going to see what else I need to do here up here. Okay, and also remember that we need to give it an initial old button state. So I'm going to say but state old is going to be equal to 0, meaning that last time through the loop it wasn't pressed. So that way the first time through the loop it doesn't crash. We seed it with a value. And this I've been doing. Hopefully that makes sense. Okay. Now what I need to do down here is I need to go ahead and set up my watch button, and that's going to be the button that I'm connected to, the pin that I'm connected to, and that is going to be pin. And what was the pin? It was but pin, which was pin 20. Okay, but pin was pin 20, and then that was going to be a pin dot in, and then we were going to put the pull. We were going to activate the pull down resistor. So pull underscore down. So all of this is kind of from that picture that I showed you earlier. Then I need to go ahead and set up my red LED, and that's going to be pin, and that's on the red pin, and that's going to be pin dot out. We'll make that an output. Now I need to attach an interrupt to that watch button, and so I will say watch button dot interrupt request like that. And then how are we going to trigger? Trigger is going to be pin IRQ what? Okay, IRQ what? You guys tell me. Let's go back and look at this, right? What do I want to look for? Okay, I want to look for a rising edge. Also, I want to look for the falling edge. So this is kind of the trick, okay? If we look at this, if I'm going to keep track of T up and T down, do I trigger on the down? Do I trigger on the button up and the signal down? Or do I trigger on the signal up, the button down? I have to trigger on both. I have to trigger on both, because if I'm going to find T down minus T up, I've got to keep track of T down and T up, which means I must trigger on both the button going down and the button going up. All right. Hopefully this is making sense what I am saying. And so what I am going to do is I am going to trigger when the signal is rising, meaning the button is going down, or that vertical bar above your enter, the shift, the button above your enter, that or pin.irq underscore falling. So I'm going to trigger on both events because I've got to keep track of both things if I am going to debounce. Now I got to give it the handler. Okay, I got to give it the handler. Let's make sure that you can see what I am doing. Okay, like that. The handler is going to be equal to a function, and I'll just call it the interrupt switch function. And that is how we're going to do that, and I will just close that. Now, if I'm going to use interrupt switch, I need to come up and I need to define it, and that needs to be up here above all this other stuff. And so right here, I'm going to define the interrupt switch function. Okay, so what are we going to do? I need to go ahead and do my try and except stuff down here too, right? We want to cleanly exit on a Control C, and we want to turn the LED off while we are when we do that. And so I'll put a try, and then I'll put my while true. When it's true, true, true is always true. And the assignment was to do nothing in your main loop, to do everything as part of the interrupt. Don't do anything in the main loop. And then we will have the except, and that is keyboard interrupt, like that. And then when we interrupt out, we'll say the red LED goes off like that, so we can cleanly exit. All right, so now we've got the bookkeeping of the main program working, and now we've got to define this int switch callback function, or the handler, I guess we should call it. So I'm going to define, and I'm doing it after I've set up my variables, but before I set up the interrupt. After I define my variables, but before I do the interrupt command. So I'm going to define that now, and that is the int switch, like that. You got to pass it something. I'll just say pin. It's got to have something in there. All right. Now, I need some global variables. Global. I need that initial T up that I defined up here. That's got to be down here, T up. Okay. Then also, I'm going to need the T down, and then I'm going to need the but state old. Now, why do I need but state old and not but state? Because I'm going to read but state, but the first time through the loop, the but state old doesn't have a value. So I've got to set it up here, and then I've got to use it down here. So that's good. Now, the first thing I want to read is I want to read where is my button. So I'm going to say but state is equal to the watch button dot value. Okay, so now let's go back and let's look at our picture. All right, if the button is down, if the button is down, I'm going to read a 1. If the button is up, I'm going to read a 0. So but state is a 1 when the button is pressed. But state is a 0 when the button is released. So let's just keep reminding ourselves of that, and hopefully you drew that. Okay, hopefully you drew that. So now I know but state here. So what do I say? Well, if but state equal 1, what does that mean? That means that the button was pressed. The button has just been pressed down. How did I end up in this handler function? The button was pressed down. If but state is equal 1, then what? I need to record that time. That means the button was pressed down. And so T down is going to be equal to time.ticks underscore milliseconds, like that. So now I have the button down time, right? That was very important over here, right? The button down time here was very important. So now I have that. Okay, so let's come back to the code view. I have that now. When the button is pressed, I record the time at which the button was pressed. Now, if but state equal 0, what does that mean? The button was released. How did I get in the handler for this case? The button was released, but state is now 0. So now what do I need to record? Time up is equal to time.ticks underscore milliseconds, like that. All right. So now If I got into it by pressing the button down, I have the T down. If I got into it by releasing the button, now I have T up. Okay? Now this is where the action happens. If but state old equals 0. That means last time through, the button state was 0, meaning the button was not pressed. And this time through, but state equal 1. So last time the button was not pressed, this time the button was pressed. And if T down minus T up is less than, let's say, 25 milliseconds. Now, why did we say T down minus T up? Because I am trying to trigger on this button push, and so I need T down minus T up, and I need to see a long gap here that is more than 25 milliseconds. Okay, now in that case, what do we do? In that case, I have a bona fide toggle event. So I'm going to say press is equal to press plus 1. And if I'm going to do that, then I better make press a global variable because I initialized it up here. Right, so I've got my global variables now. So press is press plus 1. So that means I've got a bona fide toggle, a bona fide button press there. Okay, now just to see it, I'm going to say print that I've actually triggered. And then I want to see how many times have I triggered, press times. And this will help me see, like, if I press it and I see it say triggered and I see it says press is 56 times, that means that I didn't filter out those bounces. And then what do? Red LED dot toggle, like that. Okay, now we got to do some bookkeeping here. And now what do we have to do? We got to get ready for that next. We got to get ready for that next time that it's called but state old is now equal to but state. So next time I come in here, but state old is going to be what but state was this time through. Okay. So let's see. I'm sitting there and I press the button. When I press the button goes down and the but state goes to 1, and then I record the T down time. Now I'm going to compare T down to the last time I released it, and I want to see more than 25 milliseconds. And if I see more than 25 milliseconds, I'm going to take that as valid. So let's see how many terrible mistakes I made in here. So line 13 right off the bat, what is that it doesn't like? Invalid syntax press. Line 13, T up, T down, but stayed old. Do I have all these? T up, T down, press is up there, but stayed old. Man, that sure looks right. Do you guys see my error? Press T up, T down, but stayed old. Man, that looks right to me. Int switch pin. T down, but state old, press. Did I misspell global, Global? I've got my colon in there. Wow, that looks good, doesn't it? Man, somebody tell me what the error is. DEF colon. I wonder if I got like a... Let me take these white spaces out. Wow, this really has me perplexed. What if I just take that line out and just see? Now it's going to crash when I enter there. Well, at least it... Global. So what if I just got rid of those and just said press? Line 10, it does not like. Even just with press, it doesn't like it. P-R-E-S-S. P-R-E-S-S. Sometimes you are so perplexed, you just got to unplug it, reconnect it. How silly. No equal signs. Okay, that was painful, wasn't it? That was painful. That was painful. I'm sure it was more painful for me than it was for you. Now let's try running it, okay? So we're going to run it. It ran. Now I'm going to press the button. And okay, now I'm pressing the button, but I'm not getting any type of trigger event, okay? There it triggered. Okay. I think I see what I did. Okay. I did this wrong. That what I wanted was I want to count it as a real trigger if there's a long gap. So that should have been greater than. Does that make sense? Let's come back over here. And remember, I want a long gap here, a long gap. So it should have been greater than that. Okay, so we'll come back over here and we are going to run it. And now I'm going to press the button, and on the down, boom, and on the up it stays. On the down, boom, on the up it stays. On the down, boom, on the up it stays. Okay, now let's really shake this thing out. So what I want to do is I want to give it 10 quick. I want to give it 10 quick button pushes. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfectly debounced for quick. Now let me give it 10 long button pushes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 slow button pushes, 10 long button pushes, and it worked. Now let me give it 2 quick. Let me give it 2 quick pushes, push, like that. So it's going to go on, off, on, off, on, off, on, off, on, off. Okay, that worked. Now let me wiggle it around while it's down. So 1, wiggle it around, 2, wiggle it around, 3, wiggle it around, 4, wiggle it around, 5, wiggle it around, 6, 7, 8, 9, 10. Okay, there, boom. All right, so now let's just go fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. Now let me go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I did like 60 tests on that thing and I did not see a single misstep. If I missed one, I was trying to be very careful watching it, but I would say that this thing is fully debounced and fully debugged at this time. And what I want you to see is really, don't forget the assignment was to do this, but with nothing but a pass in your while true. And then also the other part of the assignment was not to use a time.sleep, because you might try to get around some of this thing by just sort of, you might try to get around this business by just sleeping through, like after you see a rising edge, just by sleeping for a certain amount of time. No, you were to do it without a time.sleep, and you were to do it without doing anything in your main while loop. Okay, now, what is your homework assignment? What is your homework assignment? This is your homework assignment. And let me get this thing running here. Give me just a second. And I think this was kind of a neat assignment. So what your assignment is going to be is, I'm trying to get it where you can just see only what I want you to see. I'm almost there. Okay, so now this is what your homework assignment is, and this is why I had the 4 LEDs connected. What I want you to see is, in your main program, you have nothing but a pass, and so you are doing this with background functions. You're doing this with the background type functions that you learned. Now, what I want you to watch is, I am going to run the program. Okay, and then I will come over here, and what your assignment is to create an LED binary counter without anything in your main while loop, everything done with interrupts or timers or, you know, whatever other things you've learned. And now watch this. I press once and I go to a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and back around the horn to 0. Okay, did you see that? And again, I must show you and I must remind you, all of that is done with the while loop being empty. Okay, now also what I want you to see as part of the assignment, that if I'm sitting here counting, and then if I Control C out of the program, if I Control C over here, Control C out of the program, it turns all the LEDs off. So the next time you run it, it will be ready to run fresh. So that is your homework assignment for next week. Okay, guys, I'm sorry I made that mistake with global equal, and I just did not see that. So that took a little bit of time, and so had a couple of hiccups along the way, but you know, you learn by making mistakes and you learn by debugging, and sometimes I'm deliberately not so careful just so that you can sort of see how you have to think through things. And that one, embarrassingly, was kind of an obvious mistake that I should have found sooner. But anyway, we got to the end of it. So anyway, I hope you guys are having as much fun taking these lessons as I am making them. If you enjoyed the lesson, give it a thumbs up. Also helps me if you'll leave a comment down below. And most especially, I want to thank you guys that are standing with me on Patreon. YouTube is just really not showing me any love these days, and it's sort of like I'm not part of the type of format that they really want to promote, and so it's really I'm not getting any help at all from YouTube. So you guys on Patreon are keeping this great content coming. And then finally, and most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.